Now, we will cut the other PET bottle along 2 guidelines. In this video, we are using an opaque white bottle so that the 2 lines show up clearly. As it is a bit difficult to pierce the bottle with the pointed tip of the scissors, we will make our initial cuts with a cutter. Be careful when handling the cutter because the bottle's surface is very slippery. Cut the line that is closer to the bottle's mouth. Then, do the same for the second line. Scissor off the part near the bottle's mouth first. Next, cut the nose cone from the bottle's body. Scissors for use with PET bottles are available. We recommend you use this type. Here's the part of the bottle we've just cut off. It will serve as the core structure of the nose cone. Next, we'll proceed to adjustment of the water rocket's balance. Using modelling clay, apply a sizable lump of clay to the front end of the bottle proper. Please make sure the clay is applied evenly to prevent the rocket from listing to one side or the other. Test the rocket's balance by placing it on your finger like so. The centre of gravity should be closer to the nose cone to ensure a well-balanced flight. Push the nose cone over the water rocket and tape it securely into place. The rocket is nearly complete. The final step is to use the vinyl bag to fill the empty space in the nose cone to create a cushion against the impact the rocket will absorb when returning to Earth. Use vinyl tape to keep the bag securely inside the nose cone. In order to launch the rocket, we need to fit this PET bottle with a nozzle. Screw the nozzle onto the PET bottle. Make sure the nozzle's opening protrudes beyond the tail fin cylinder. The water rocket has now been completed. Although our rocket looks like this, your students can choose whatever colours they like. They can even draw pictures on their rockets. The idea is to enhance their enjoyment by allowing them to make their own original rockets. For junior high and high school students, you might challenge them with a series of questions. For example, how will the rocket fly if fin sizes are changed? How will it fly if they change the weight of the nose cone's ballast clay? Next, let's proceed to an explanation about the launcher. We need a nozzle like this to launch the water rocket. First, screw it onto the rocket's mouth this way. Then, set this launch gear as shown here. After pumping air into it, the rocket will be ready for launch. The launcher is used to set the direction of the rocket's flight. For this demonstration, we've made one like this. Here we used 4 pieces of wood to hold and guide the rocket. With the launcher set accurately to the desired angle, insert the water rocket into the space between the supports. Then attach the launch gear to the tail. Since our launcher is made of wood, we've coated it to protect the wood from water damage. This launcher is designed to be adjustable. The angle of launch can be modified as desired. If you have access to a wide open area, it would be safer to launch the rocket at an angle as shown here. Otherwise, you can launch it straight upward. Various other types of launcher are possible. A common type, for example, is this one using steel pipe. With this launcher, we attach a piece of PVC pipe to the rocket body and run the steel pipe through it like this. Attach the launch gear and you are ready to go. The water rocket is now ready for launch. Here are some points you need to consider when selecting a launch site. Water rockets can fly a distance of about 50 metres on average and as far as 100 metres if conditions are favourable. The site must be at least 50 metres long and wide enough to accommodate a rocket that has deviated from its intended course. It will also be better if the site is where you can discharge water without disturbing others. If your intended site is close to an